A vast amount of subjects apply to permutations. Permutations are the sorting of objects in set positions in different ways. The most basic question we ask regarding permutations is how many different ways can we sort distinguished objects? For example, take these 3 different colored mugs. If I reordered these mugs every way possible, I'd have 6 different possibilities. So there are 6 different ways to place 3 mugs beside each other. This wasn't a hard task, because it's easy to list every possible way to sort 3 objects and count them. But what if we had a lot of them? We certainly wouldn't have the time to list them and count them. We'd have more important things to do, like go to the store and buy groceries or something. Let's do a bit of reasoning to find a better way. Let's set positions for each mug and figure a way to build a strategy for counting the permutations. Since we want to be able to count the permutations for any given number of distinguished objects, we aim to figure out a function where the input is the number of objects and the output is the number of permutations. We can try starting with just having one position and rotating each mug through that one position. It isn't too hard to see. There are only 3 ways we can do this. Since there's only room for one mug, and I have 3 of them, there are only 3 ways that this can happen. Now that I've placed the first mug in a position, I'll put that one to the side. Keep in mind that it doesn't matter which mug went there. It only matters that I have 2 left. We apply the same operation. We rotate the mugs into the second position and find there are only 2 ways to fill the second position with a mug. Remember, before we did this, we had to fill the first position. The first position had 3 possibilities. For the second position, we are less 1 mug and only fill it 2 different ways. If we consider all the ways we can fill 2 positions with 3 mugs, we find that we have to multiply the ways of sorting the first position with the ways of sorting the second position. In this case, 3 times 2 is 6, so there are 6 ways to fill 2 positions. Next, we consider the third position, which in our case is the last position. We only have 1 mug left, so there's only 1 way to do this. We conclude by saying that the amount of ways we can sort 3 distinguished objects is 6, which is the result of multiplying possibilities of each position as we place the mugs there. It can be cumbersome to have to write the product with numbers when there are a lot of them. Whenever there's a pattern that is commonly used in mathematics, we give it a shorthand notation. In this case, we'll use the factorial notation, which just means to multiply all the numbers from 1 to n. The notation looks as if we're just really excited about the number. We were able to deduce the pattern regarding the assortment of objects in positions, but we ended up having to multiply the amount of objects left over 1 by 1. Sometimes we have to complicate things to make it simpler. Since we want to use our factorial notation, we use a trick that essentially removes the smaller number from the product. When we expand the factorial, we can see that the smaller numbers in the denominator cancel out the smaller numbers in the numerator. And now we can generalize the entire thing. We know that if we have an n number of objects and we want to know how many ways we can sort them into p positions, we multiply all the numbers starting from n and decrease by 1 until we have a p amount of those numbers. We can express this with the ratio of factorials. Now let's give an example of a situation we wouldn't want to do by hand. Given 100 mugs and 95 positions, for example, like 95 boxes, how many ways can they be sorted? There should be 100 factorial divided by 5 factorial ways of sorting them. Thank you for watching.